Okay, we find ourselves in the last section or sections of this unit. So I gave you a page. If you're watching the video, this is attached as a PDF in your Canvas shell. You can print this out, follow along, or just have it on the screen. So I put the problems for 6.5 and 6.6. Both of these sections are related, so that's why I just go ahead and do them together. So they both involve various types of problems involving fractions. So 6.5 and 6.6, we have problems involving fractions. Okay, so the first couple of problems are just going to remind us of the skills we were working on when we left class last time. We spent the whole class solving equations. So we're going to get to practice that a little bit. So first example that I have up at the top says this. I've got this formula that you'll see in some science class at some point in your future. It says we've got 1 over f equals 1 over p plus 1 over q, has something to do with lenses. What we're going to do is we're going to find the value of q if p is 20 and f is 10. So I've given you a couple values. We're going to find the unknown value, pretty common thing to do as an application, whether it's in a science class or an economics class or some other place that you use a formula. So I've got 1 over f is equal to 1 over p plus 1 over q. I am given that the value of p is equal to 20 and f is equal to 10. We are going to find the missing value. Great. This allows us to get back up to speed with what we were doing last week. So let's first plug in the values. So p is 20, f is 10. So this first thing, instead of 1 over f, is going to be 1 over 10. Instead of 1 over p, I'm going to have 1 over 20. I'm just putting the appropriate value in the appropriate place. And then that's equal to q. Okay, so from the last class, from last week, who can remind me? You don't have to tell me exactly what to multiply by, but what's my process? What do I want to do to this equation to get rid of the fractions? We're going to multiply by the lowest common denominator. That is indeed true. So that's what I want to do. Multiply everything here by the lowest common denominator. So in this case, thank you very much. You predicted my next question. I love it. So we're going to multiply by the common denominator. What is the common denominator between 10 and 20 and q? You gave me part of it. I've already heard 20. What else do I need as part of my common denominator? The q. Okay, I need one of everything. So I'm going to multiply each of these terms by 20q. So good. We haven't seen each other in 5 days. And in those 5 days, you remember that we have to multiply by the common denominator. So that's good. And once I do that, I'm going to be able to solve for q. It's not going to be, that's probably not going to be the most difficult part to this problem. But again, this is the new part. This is difficult. It's tough to solve equations that have fractions in them. So, as we go through class, as we finish up these last problems from this 4th unit of our class, if you've got any questions, please ask them. So here I've got 20 over 10. 20 divided by 10 leaves me 2. So I have 2q. 20 divided by 20 is 1. So I have 1q as my next term, or 1q is just going to be q. And then plus here, the q's cancel. And so I have 20 times 1 or 20. Just a linear equation. Our process for linear equations all semester is I'm going to get all of my variables on one side. I'm going to get my numbers on the other side. So I'm going to get my variables on one side by subtracting q and getting all the q's on the left. So I will do that. Minus q, minus q. 2q minus q is 1q. And then I get 20. So this example at the very top of the sheet said I gave you this formula. I gave you 2 values. And so then we wanted to find the third value, and we just did. So you're going to do the same thing. Problem 1 says, okay, now find f if p is 5 and q is 10. So you're going to use this same formula that we did for the example, and I've just given you 2 new values, and you're going to find the third one. All right, I'm going to put the appropriate number in the appropriate place. So in the problem, I told you P is 5, Q is 10. And so here we go. So I've got 1 over F is equal to 1 over P, which P is 5, and Q is 10. So 1 over Q is 1 over 10. So there's step number 1 to get the relevant information in the appropriate place. Then step 2, I've got to clear these fractions. I don't want them to be around anymore. So what is that common denominator? I'm going to multiply everything by. Okay, we need a 10. The common multiple between 5 and 10 is 10. You can use a bigger number if you want. You can use 50, you can use 20, that's fine, but I'm going to use the least, 10. And then I also need an F as part of that. So 1 of everything. So I'm going to multiply everything by 10F. So we multiply every single fraction by 10F. So over on the left, F's cancel. Good, that fraction's gone, so I have 10. Here I have 1 over 5 times 10F. So 5 goes into 10 twice. So I have 2F. And then here 10 goes into 10 once and just leaves the F. So this one, all of my variables are already on the same side of the equation. So 2 plus 1 is 3 of them. I'll divide both sides by 3, and that is going to be my last step. And so the value of F this time is 10 divided by 3. So these first 2 problems gave us the ability to kind of think back to what we saw last time and clearing the fractions using common denominator in order to solve equations. So now we're going to take the next step. There will be some class that you go to, some science class or some other class that you're gonna be part of, and you are going to get some sort of formula, and you are going to have to rearrange it into a format that is more usable. So we're going to take this formula that we've just done these first couple problems. 1 over f is equal to 1 over p plus 1 over q. What I'm going to do is I want to solve this. My instruction is we want to solve this for p. I want a statement that says p is equal to something. Okay, so we're going to solve this for p. Well, my first step is not going to change from what we've done. I want to clear the fractions. I do not want any fractions here. They gross me out. So here we go. What is the common denominator of these fractions that I'm going to multiply everything by? I heard somebody say it. FPQ, you need one of everything. Remember, that's been my instruction for the common denominator since the beginning. You take one of every factor you see. If you have powers, you take the highest power. There's no powers here. So it's just one of everything we see. I see an F, I see a P, I see a Q. That's the common denominator, one of everything. So FPQ here, FPQ, FPQ. Multiply everything by that common denominator. All right, first term, when I multiply by f times p times q times 1 over f, what happens with this first one? F's cancel, yes, and I just have p times q. Here's my equal sign. Let's try again. I take my f times p times q times this fraction. What happens? The p's cancel, and I have f times q. Great, plus f times p times q times 1 over q. What happens with this last one? Yep, the q's cancel, and I have f times p. Okay, so here, I don't know that that's necessarily too difficult. You know, the common denominator was just one of everything. We multiplied, we got rid of the fractions. But here's the step that I need you to pay attention to. Okay, like over here, we cleared the fractions. We immediately had something with like terms. I could combine those like terms and then divide. Unfortunately, what happens here is I don't have any like terms. But I do notice how many terms have the letter P that I'm solving for. Yeah, I've got a P right here. I'm going to put a check mark over it. Then I've got a P right here. I'm going to put a check mark over it. So if I'm solving for P, I have to get all of those terms on the same side. Okay, just like over here, we were solving for F. I got everything, well, it was already happened, but I got everything with an F on the same side over here. So tell me, how am I going to get this term, this F times P? How am I going to get this over here on the other side of the equal sign? What am I going to do? I'm going to subtract. It's already being added, so the opposite of adding is to subtract. Now here's where I said we don't have like terms. I can't smush these together. I've got P times Q minus F times P. These look nothing alike, so I have to keep them separate. So I have PQ minus F times P. On the other side, I should not have anything with a P in it, and I don't. F times Q, that's it. Okay, back in chapter 5, the unit before this one, when I saw that I had the same thing in more than one term, what can I do with that? What did we do in chapter 5 when we had the same thing in more than one term? We factor it out. Yes. So my goal is to solve for the P. I got everything involving a P on the same side, and now I'm going to factor it out. So we factor out the letter P. Now we're almost done. This is the difficult step to this problem. And that's why you're going to do 2 problems very similar to practice this. When I factor P out, P times Q, when I factor P out, I have Q minus F times P. When I factor the letter P out, I just have F. Last step, we're finally at the finish line to this. I'm going to divide. If I want to get the P alone, I have to divide by all that other stuff. So I have to divide by the Q minus F. Nothing here is like terms. You can't simplify anything. It's just going to look the way it looks. So the Q minus F, those cancel, and I'm left with P is equal to F times Q over Q minus F. So what we've done is we've rearranged the original formula into it's solved for P. It says P equals. That's a difficult problem. Okay, and I know that's difficult. That's why we're going to practice it a couple times. So problem one, right below that, I give you another formula, 1 over m minus 2 over n equals 5, and I ask you to solve that for m. Clear the fractions, and then solve for m. Bless you. Just to make sure we're all heading the same direction. What's the common denominator of this problem? M times n, one of everything you see. I see an M, I see an n. There's no the denominator of this is 1. It's not written. So there's nothing there. 5 does not contribute anything to the denominator. So keep going. I'm just going to write this down, and then we'll do this together in a minute. M times n. So when I multiply everything by m times n, the first fraction, hopefully you said the m's cancel, goodbye. And so I have 1 times n, which is just n, minus the next one, 2 over n times m times n. Well, the n's cancel, good, no more fractions. So I have 2 times m, so 2m. And then over here, don't forget, this is one of the common mistakes students make. I know there's no fraction over here, but you still have to multiply this by the common denominator. You've got to multiply every term. Otherwise, you've changed the equation. You can't do something to one side without doing it to the other side. Otherwise, your equation will be out of balance. So on the other side, I've got 5 times m times n. There's nothing that'll cancel, and there we go. So if you did that step, you have done a wonderful job of clearing the fractions, and that is worth celebrating. That is good. And now this problem I asked you on the instructions, it says solve this for m. Let me verify that my short-term memory is functioning. Yes, solve for m. How many terms have an m in it? 2. I've got an m right here. I've got an m right here. So you can't just divide by the 5 and the n. You can't have if you're asked to solve for m, you can't have an m on both sides of the equal sign. It has to just be one m. So that's why we have to go through this process. So what I'm going to do is I'm going to bring the 2m over here. How am I going to do that? I'm going to add it. You always do the opposite, the reverse. So when I do that, I'm just left with n. That's good, nice and lonely over there. These things are not like terms, so I can't add them. Don't force them together. So I have 5mn plus 2m. I'm going to factor the m out of both sides of this again, because it's in more than one term. That's why we have to do this. So when I factor m out, when I factor m out of the first term, I have 5 and n left over. When I factor m out of the second, I have 2 left over. That's, I think, probably the most difficult part to this problem. That's why we're doing a couple of these. So now the last thing is I will divide by that to get it away from the m. And so what I'm left with is I'm left with m on the right side. And on the left side, I have n in the top. And for some reason, I wrote an m here, sorry. I have a n on the top and a 5n plus 2 on the bottom. And there is my equation that's been rearranged and written in a new format. So it says m equals. That's what solving for m means. Write it in the format m equals. Over here, that's what solving for p meant. Write it p equals. And on the other side of the equation on this one, I should have no p's. On the other side of the equation on this one, I should have no m's. And we achieved that. Try it again. Problem 2 asks you to do something similar. Something I just want to make you note in problem 2, you'll encounter this again when you get to places where you use formulas. Case matters. So you notice there's capital N in that problem and lowercase n. Those are different things. Okay, so capital N's are go with other capital N's, and the lowercase n is a separate factor. On this problem, what's the common denominator? the only denominator, right? The n minus n. Okay, so keep working. Just want to make sure if you're struggling with that. Common denominator here is the only denominator. N, capital N minus little n. Capital N minus little n. All right, so here goes. Check your work with my work. If you got a question, get active, ask it. Happy to answer any questions I can. So n, capital N minus little n is the common denominator. So on the left, it just cancels. That's great. And so I have capital N times capital R. On the other side, I've got t times capital N minus little n. So t times capital N is t capital N. T times little n is t little n. Great. I think anything too drastically bad right there. Now, we're solving for capital N. How many terms have a capital N in them? I got one right here. I got one right here. Great. So now I'll get those on the same side, just as we did in this problem, just as we did in the problem before. So how am I going to get this t times capital N over to this side right here? Subtract. It's positive right now, so I will subtract it. We always do the reverse. Again, these are not like terms. These are completely different things. So I've got the capital N, capital R minus t times capital N is equal to negative Tn. This term I'm going to do nothing with. It is what it is. It's going to stand that way. I am now going to factor out this thing I'm solving for, this capital N. You can see once you've done one or two of these, I know they're difficult, but once you've done one or two of these, it's the same steps every time. It's clear the fractions. It's get every term involving your variable on one side of the equation. Bless you, by the way. So you can factor and divide. And so we're going to do that. When I factor the capital N out, I have capital R minus, when I factor the capital N out, I've got T. And last but not least, I divide. And I have my capital N is equal to this chunk right here. Negative Tn over R minus T. So this is solving these formulas for different variables, putting in values and solving like we did. This is the first part of section 6.5. The last bit of section 6.5 is going to be working on what's called proportion problems. Again, we're just mopping up the end of this unit with some things that we see that involve fractions. Okay, so proportion problems. Our next couple things we do are proportion problems. probably one of the most useful skills is solving proportion problems that you'll see in this class, as far as times you'll use it, not in a math class. So solving a proportion problem. It says here in our first example, at a gas station, 3 gallons of gas cost $12.27. How much would 13 gallons of the same gas cost? Okay, so the premise to a proportion problem is I'm going to set up two fractions. I'm going to set up two rates that are equivalent. The first one is going to be one that I know both parts that I can set up the rate to. And the second one is going to involve what I'm looking for. So what all that means is this. What part of the problem do I know the relationship between my two things? Okay, I know that 3 gallons of gas costs $12.27. That relationship has been given to me. It's right there. So what I'm going to do is I'm going to make a fraction. It's called a rate. Okay, and so I'm going to say that 3 gallons, I'm going to abbreviate, gallons is gal, and then in the denominator, it's $12.27. Now you might say, hey, Perkster, could I put the $12.27 in the top and the 3 gallons in the bottom? That is a worthy question. So I'm going to show you that it absolutely does not matter, but there is one point of consideration. So if you would have said, hey, I would have done $12.27 over 3 gallons, would that be legal? And the answer is yes. Okay, so 3 gallons, $12.27. I am given that information. Those go together. Now it says how much with 13 gallons of the same gas cost. So I'm going to put an equal sign here. And I'm going to make another fraction, another rate, only this time I only know half of it. What information am I given about this rate right here? The 13 gallons. Now here's the key question. Where do you think, since I have 3 gallons here in the top, $12.27 in the bottom, where do you think, according to the way I've set it up, I'm going to put the 13 gallons? In the top. That is the point of consideration when you are solving proportions. The same units go in the same part of the fraction. I don't know how much this is going to cost. I'm going to call that X. So if you would have said, hey, could I put the $12.27 in the top, 3 gallons in the bottom? The answer is yes, as long as on the other side, where do I put the 13 gallons now? In the bottom. Same thing. It doesn't matter which way you do it. Now, we have been clearing the fractions, and what I'm going to show you is based on clearing the fractions. I'm going to show you a shortcut. When you have one fraction on the left and one fraction on the right, when you clear the fractions, it basically becomes this. Okay, this is something, I don't like to use this term, but I'm sure you've seen this before, and you've been told to cross multiply. Okay, and what that means is I'm going to multiply the 3 times the x times the 1227 or 1227 times the 13. The reason I don't like the term cross multiply is then when we go to multiply fractions, you think that's what that's called. So I'm just going to call it, I'm going to multiply along the diagonals here. So I'm going to multiply the 3 times the x, and I get 3x. And that has to be equal to, on the other side, I'm going to multiply the 1227 times the 13. I can't do that off the top of my head, so I'm going to get my calculator. And so I've got 1227 times 13, and that is 151, or excuse me, 159.51. So when I now divide both sides by 3, I get that the missing value, the missing x, is equal to $53.17. Units are important. We were asked how much, so the units are dollars on this problem. And that's how you solve a proportion problem. You'd get the same thing over here when you multiply along the diagonals. And multiplying along the diagonals is just based on clearing the fractions. My common denominator would be 1227 times x. And so when I multiply 1227 times x over here, the 1227s cancel, and I have 3 times x. So this is just a shortcut when you have one fraction on the left, one fraction on the right, which you will have when you do a proportion. So problem one, right below it, same thing. It's just a proportion problem. Give it a try, at least set it up. If you don't have a calculator, you can wait to do the calculations, but set up the proportion in problem one. All right, let's give this a try, see how you did. It says on a map, the distance between Reno and Phoenix is 2.5 inches. The two cities are 768 miles apart in reality. On this same map, what would the distance between Chicago and El Paso be if they are 1,606 miles apart? Okay, so the first thing I have to do for my proportion problem is I have to determine what is the relationship that I am given. What do I know? So what am I told goes together here? Okay, so on the map, 2.5 inches is the same thing as the 768 miles. Okay, this is the distance apart on the map. This is the distance apart in reality. Okay, we are told that those two things go together. Again, if you have the 768 miles in the top and the 2.5 inches in the bottom, that is totally wonderful. Okay, just make sure your other fraction is reversed. Okay, now on the other side, I am given that Chicago and El Paso are actually 1,606 miles apart. So where am I going to put the 1,606? On the bottom, because that's where I put miles. If you put miles on the top, then you put the 1,606 on the top. I don't know what that is, so I will call that X. And now I'll grab my calculator and we will take care of this. So the nice thing about proportion problems is setting it up is the hard step. What did I do wrong? Okay, that's the answer? Okay, great. Let me just multiply this out and show where we got that, but that's awesome. So what I'm going to do here, and I turn on my flashlight for some reason, that kind of day. Okay, here, that's better. So I've got 768 times X is equal to 2.5 times 1,606. And that is equal to 4,015. There you go, just like I was told. And now I'm going to divide both sides by 768. And when I do that, I have 4,015 divided by 768 is 5.22 and a whole lot of change. I didn't give you any instructions about rounding. So let's just round to the 10th place. On the test, I'll be sure to let you know on MyMathLab, follow their instructions. So that's going to be 5.2, and the units of my numerator up here are inches. That's how far apart on the map they would be. I got another example for you. So flip the page, page 2 of our sheet. Similar problem. Go ahead and do problem 2. Set up that proportion, solve it if you've got your calculator. All right, so problem 2, which I wrote problem 3, that seems to be about on par today. Let's try this, problem 2, okay. So it says on a world globe, the distance between New York and Cairo, which are 5,619 miles apart, that is 8.5 inches. On the same globe, how far apart are Madrid and Rio, which are 5,045 miles apart? Okay, so the same sort of thing that we just did. We'll round our answer to the 10th, but what I'm most concerned about is setting up the proportion because that's kind of a new thing. So what is the relationship that I am given in this problem? Fantastic. 8.5 inches to 5,619 miles. Either you have it like I've set it up or you have the miles in top, inches in the bottom. Either way is fantastic. Then I am told that 2 other cities are 5,045 miles apart. So where am I going to put the 5,045? In the bottom? Great. So I don't know what the top is. So at this point now, it becomes a calculator problem. Now that we've got the proportions set up. So when I do this, I've got 5,619 times x is equal to 8.5 times 5,045. And that turns out to be 42,882.5. Last but not least, I divide and then I'll round to the 10th place. And when I do that, we end up with 7.6. one more proportion problem, and then that will be the end of section 6.5 material. And then we'll have just a few problems left from section 6.6. So do problem 3, that's right up at the top. It's one more proportion problem. So for problem 3, it says at one point in the 2013-14 NBA season, the Indiana Pacers had won 48 of their 65 games. If they continued to win at the same fraction of its games, how many games would the Pacers win for an 82-game season? Okay, so we want to make a projection on where we think they're going to end up. So what's the information that I know? What's the rate? Okay, 48 wins over 65 total games. Great. 48 out of 65. So now this one might be a little bit more vague. Now we're given that the complete season is 82 games. So where am I going to put the 82? Does 82 represent wins, or does 82 represent total? It represents the total. We want to know how many wins. That is the question. So we're going to put the 82 total in the bottom, and then the number of wins in the top. Okay, once you get everything in its appropriate place, now it's just a matter of multiplying along the diagonals. So I have 65 times x is equal to 48 times 82, which is 3,936. Divide by 65. Now this one we're going to round to the whole number, because for basketball games, there's no decimals. You don't play 82.5 games or anything like that. So we'll divide this by 65, and we'll round appropriately. So that means that they're going to maybe win 61 games. Is what we're hoping for. There's proportions. Before we move on, anybody unclear about anything on any of these proportion problems that we saw? We did 4 proportion problems. Anything I got to clear up? Well then, the last bit for this unit, Unit D, your 4th unit. After you have your test this week, you've got one more unit to go. You're almost done with this class and done with me, and hopefully you move on to college algebra or whatever math's coming next in your life, and you do a great job. So the last thing from this unit, we're going to talk about what's called variation. What variation means, okay, is the relationship between variables. And in this class, we are going to talk about 2 kinds of variation. Okay, there are other kinds, but once you get used to doing this, Other kinds of variation are really no more difficult once you get used to this. So for us, we are going to do two things. We are going to look at direct variation, or in other words, a way you might say this is y varies directly as x, and that might be the phrase you see. Two variables vary directly with each other. And the other type of variation we're going to talk about is what's called inverse variation. And again, the way you might say this, or the way you might see this presented in a problem, is y varies inversely as x. Just give me a moment to catch up. Okay, so I've got direct variation, I've got inverse variation. So I've told you these words. Now, what in the world do they mean? How does this look? So when two things vary directly, here's what the pattern is. If I tell you that y varies directly as x, here's what I am communicating to you. That y and x, when it varies directly, means as y goes up, x is also going to go up. There's a direct relationship. As y goes down, x is also going to go down. They're doing the same thing. They are in direct relationship to one another. So the way you express that as an equation is this. You will say, whenever you see a varies directly or a direct variation, that is y is equal to k times x. And k is just some number. It's a constant. Something we're going to have to find. It's what defines the relationship. So a direct variation means that y is equal to some number times x. That's what direct variation looks like. And we're going to do problems. We're going to put some numbers to this, but I'm just giving you the general content first. Inverse variation. When I tell you y varies inversely as x, what an inverse variation is this. That as y goes up, an inverse variation means then x is going down. And vice versa. As y goes down, x is going up. They are in inverse relationship. They're doing opposite things. And so when you are told two variables are in an inverse relationship or vary inversely, here is the mathematical way that they're related. It's y is equal to k, which is again my constant, divided by x. And hence, that's why this is in this unit, because we've got a fraction, in case you were wondering. Those are the two types of variation that we are going to mess around with here for a little while. So once you're finished writing, I've got a problem. I've got a few problems for you. If we have time left over, we're going to take some time to review for our test that we have. I'll go into the chapter test and pull out some problems, and we'll get ourselves up to speed. Okay, so can I erase this? Not yet? Okay. Are we okay now? All right, great. So my example, which starts with the word example, says this. Hooke's law for an elastic spring states that the distance a spring stretches is directly proportional to the force. So direct proportion means the more force, the more the spring stretches, and vice versa. Less force, less stretching. Okay, so the distance a spring stretches is directly proportional to the force applied. Then we're told if a force of 150 newtons, if you don't know what a newton is, if you haven't had a physical science class, that's okay. It's just a way to measure how much force, how much pressure you're putting on something. If a force of 150 newtons stretches a spring 8 centimeters, find the value of K, and then we'll answer the question after. So we've got a lot going on there. So the first thing I have to do is I have to define the mathematical relationship. So I'm going to read that first sentence again. It says, for an elastic spring, the distance the spring stretches is directly proportional to the force. So the distance, and we're given the letter D, the distance is directly proportional. So the distance equals K times the force, F. We are given the variables D and F. That's what we're told in the problem, just so we're all using the same letters. If we were told that these two things, if distance was inversely proportional to the force, we would have done K divided by F. And that's the only difference in these problems. So we get this right here from the first sentence. First sentence tells us that the relationship between the distance D and that force F is a direct relationship. So it looks like this. Then the second sentence says, if a force of 150 newtons stretches the spring 8 centimeters, find K. Okay, so what I want to know is I want to know what's the relationship for this particular spring. What is this constant that defines this relationship between D and F? So I'm going to put in the appropriate values. We're told that a force of 150 stretches the spring 8. So I'm going to put 8 here and 150 there. So now I can figure out K. I can divide. When I divide by 150, I get K is equal to 8 over 150. You're welcome to use a decimal for that, but I'm just going to reduce the fraction because I think it's a repeating decimal. So 2 goes into 8 4 times, 2 goes into 150 75 times. There's my value for K. So what that means, if you were in science class and you had the spring in front of you, what that tells us is that tells me what the relationship between distance and force is for this particular spring. So the relationship is always going to be D is equal to 4 over 75 times F. And I can use that to answer the last part of the question. So yes. Yep. So I plugged in 8 for D, are you with me to there? And I plugged in 150 for F. Are we good to there? So then to solve for K, I divided both sides by 150. And then this is a fraction, 8 over 150, so I reduced. So I divided the top by 2. 8 divided by 2 is 4, and divided the bottom by 2. 150 divided by 2 is 75. I noticed both of these numbers were even, and I can always divide even numbers by 2. Then there's no other factors in common here. 4 is the only factor of 4 now is 2. 75 is not an even number, so I can't reduce it any further. Great. Thank you for asking that question. Let me add it. So now the rest of the problem says, okay, so we did the experiment on my spring. I figured out that the constant that defines this relationship is 4 over 75. Now what I want to know is if I apply a force of 400 newtons, how much is that going to stretch this spring? So I want to verify that this is going. So I'm going to apply a force of 400 newtons. So the force, am I going to put the force in? Am I going to put 400 in for D, or am I going to put it in for F? I'm going to put it in for F, the force. Okay, so here we go. I want to know how far is this. I've got 4 over 75 times 400. And I'm going to go ahead and go to my calculator now. And we're going to finish up this problem. So I go to the calculator and I get 4 times 400 divided by 75. I'm going to round that appropriately. So that is 21.3 centimeters. Okay, so I want you to do the same thing. Problem 1, it's super similar. It's another spring problem. It's another direct proportion. So do problem 1. Just do the first part. We'll do the second part, that sentence that's in the middle, after, just one bit at a time. All right, so let's give this a try. Ask whatever questions you have. I'm going to put a couple problems just like these ones on the test. So if you're following along, then that means good things for the test. And if you're not, then you should ask a question. So it says the force required to compress a spring is directly proportional to the change in the length. Let's stop. Okay, so the force is directly proportional to the change in length. So what does that mean for my initial relationship? What should I write down? The force varies directly as the change in the length, L. Okay, and I told you to use F and L. If you used other letters, it really doesn't matter. Just make sure you're keeping them straight. So this is my direct relationship, my constant times the variable L. It says if a force of 20 newtons is required to compress a spring 2 centimeters, find K. Okay, so this is just plug and chug to find the value of K. It says the force is 20 newtons and the change in length is 2 centimeters. So 20 is equal to K times 2. So this now allows me to figure out my constant. I'm going to divide both sides by 2. And 20 divided by 2 is 10. So what that tells me now is my relationship for this particular spring is F is equal to 10 times L. And for as long as you use this spring from problem 1, K will always be 10. So now, the next part of this problem says, how much force is required to compress the spring 12? So I got to plug in the value 12. What am I plugging in 12 for? Is 12 the force or is 12 the length? It's the length. So F is equal to 10 times 12. And so F is equal to 120. I know that you're unfamiliar with it, so I wouldn't be too fussy on this, but the units is newtons. Just a unit of force. Okay, so here's the part I told you not to worry about. Now you're going to worry about it. So we're still using this same spring. We're still using F is equal to 10 times L. So it says for the same spring, a force of 50 newtons would compress the spring how much? So give that one a try, please. Bless you. So for this problem, it says this time for the same spring, so I'm using the same relationship, F is equal to 10L, a force of 50 newtons. So this time I'm giving you the force. So this time we're putting in 50 for F. So I divide both sides by 10, and I get L is equal to 50 divided by 10, or 5, and the units were centimeters. So if you use a different force, you get a different amount of string or spring compression. For some reason, I can't say spring today. All right, last problem from this sheet for section 6.5 and 6.6. It's the same process in problem 2 that I'm going to give you, only this time notice the key word is that this one varies inversely. So give problem 2 your best try, see how much of it you can do for this inverse relationship. I'm just gonna help you with the first step. And that way you can, if you did great, you can check and see that you did great and keep going. If you made a mistake, you can fix it here. So I'm just gonna read the first sentence and we're gonna form the mathematical relationship. And then I'm gonna give you a little more time to finish the problem. It says, the current C in a simple electric circuit varies inversely as the resistance R. So current varies inversely as resistance. So what's the mathematical relationship that we write down here? C? What was that? K over R. There you go. The current, which is C, varies inversely. So I make a fraction out of it. The constant stays where it is. The R is now in the denominator. That's my inverse relationship. So now for the second two parts of the problem, you're going to find K, given that relationship, and then you're going to find the current with a given resistance. Okay, so I'll give you a couple more minutes to plug and chug the rest of that. All right, so we've set up the relationship. C is equal to K over R. So if the current is 20 amps, when the resistance is 5 ohms, find K. So we're told the current C is 20 when the resistance is 5. So I'm plugged into the proper areas. C is the current, that was 20. R is the resistance, that's 5. I got to solve this for K. It's a pretty relaxed, rational equation as far as that. So I'm going to multiply both sides by the common denominator. So multiply both sides by 5. When I multiply the left side by 5, 5 times 20 is 100. When I multiply the right side by 5, the 5's cancel, and I have K. So the value of K is 100. So here's the equation that defines this relationship. C is equal to 100 over R. And that enables me to do the very last thing, which is find the current when the resistance is 7.5. So the current is what I'm looking for. I've got 100 divided by the resistance, which is 7.5. I'm going to pop that into my calculator, and I'm going to see what I get. So if anyone already has it, you're welcome to tell me what it is. 13.3. Okay, beautiful. Love it. That's rounded to the 10. So it's 13.3. And I understand these are unfamiliar units. I'm not too fussy. But that would be amps, according to what the problem said the units for current are.